Good morning, Excel Geo. We are going to extend our knowledge today on planes intersecting our solids. So you just watched a video about conic sections. It's where planes intersect a double nap cone. So we're going to add that type of section to the sections that we've already been talking about throughout this section 11.5. Now, if you take a look at this, we're talking again just about plane sections, and we're going to look at all the solids in which we've worked with. Now, let's talk about how the sections are formed and what the sections look like when our plane intersects from different angles. So for example, we have 1, 2, and 3 here. We have a couple examples. And in these 3 examples, you'll notice that we're working with a pentagonal, a right regular pentagonal prism, and a right cylinder in 1, 2, and 3. However, we have planes that are intersecting these solids at different angles. So the first problem here in number 1, they're intersected by planes parallel to their bases. So in this case, they are intersected by planes parallel to the bases. And what happens in a case like this? Well, if you take a look at this, if we're intersected by planes parallel to our bases, you'll notice that the cross section is equal, or it's in this case, the cross section is congruent is the word I want to use. The cross section is congruent to the 2 bases. So in this example, your pentagonal cross section, we know our cross section is congruent to the 2 bases. Now, in the pentagonal prism, you're saying that the pentagonal cross section is congruent to the 2 pentagon bases. In the cylinder, you're saying that the circle cross section is congruent to the 2 circular bases. So now what happens when I change the angle in which that plane intersects my solid? Well, take a look at number 2. Now we're coming in on an angle. So we have still the pentagonal prism, and we still have the cylinder here, but we're intersecting planes that are not parallel to the bases. So in this case, it's intersected, and I'm going to add 2 words, intersected by a plane not parallel or perpendicular to the base. Okay. Now, in both of these cases, we're getting, again, in this case, I'm getting a pentagon, and for the pentagonal prism, and I'm not getting a circle. I'm going to be getting something that's more of an ellipse. So in this case here, I'm getting an ellipse because it's not going to be a perfect circle. So something that is not a perfect circle, it's more like an oval, that is my ellipse. And we saw that we can also see that when we talk about conic sections. All right. Now here I'm getting a pentagon, but I'm getting a pentagon that is not congruent to my bases. All right. In order for that pentagon to be congruent to the bases, it would have to intersect at parallel to the bases. Now let's take a look at 3. 3 is different. 3 we have intersected by planes perpendicular to the bases. So we're intersected by planes perpendicular to the bases. And what happens in both of these cases? Well, when I look at this, I have my prism, it's perpendicular. In both cases, my cross-section is a rectangle. So I have a rectangular cross-section. I have a rectangle as a cross-section in both cases. All right. So we can have the same exact solid, and depending on how the angle of that plane intersects my solid, it will determine the shape of that cross-section. All right, which is what you really investigated yesterday while doing that activity. Now let's take a look here. What if I have a parallel cross-section to a cone or a pyramid? How does this differ? Well, let's take a look at this. In this case, when you have sections that are parallel to the base when we're dealing with a pyramid and a cone, what you're going to do is you're going to form a hexagon that's similar to the base, but not congruent. Or a circle that in this case, it would be a smaller circle. All circles are similar, because we're not dealing with polygons here. All circles will have a similar ratio for their radius, their radii. So in this case, what you're going to get form a hexagon similar to the base. And here we're going to form a circle smaller than the base. Excellent, guys. All right, guys. Now we're getting into what the video that you just watched talks about, conic sections. Now, conic sections are formed when we have what they call a double napped cone, which means one cone on top of the other. Now, depending on how that plane intersected the cone, depended on the shape that was formed. Now, I'm actually going to go back to that interactive activity that we worked with yesterday. All right, and here's my double napped cone. Now, the reason I like this interactive activity is if I look over here, I see the X and Y coordinate plane, and I see exactly what that figure looks like on a two-dimensional coordinate plane. So now if I move things around, and in this case, I'm going to animate, I can move my, let's see, I can either move the slice. Well, that's not going in the direction I want. If I wanted to intersect at a parallel to the base, I got to keep on playing till I can find what works. So here, if I want to intersect so it is parallel to the base, this is a great example. If I take a look at this and I want it to be parallel to the base, right there, this looks like my cross section is parallel to the base. If you look over here on my two-dimensional coordinate plane right here, that's the plane that's intersecting my two-nap cone, you'll see that that cross section is a circle. So if I go over here and I want to say a plane parallel to base will form a circle. The only time it won't form a circle is that one scenario when it intersects at the vertex of the double nap cone. Now let's look at case 2. Now I'm going back to my interactive. If I move it so that it's not perfect, right? What are we forming if I move it so it's not perfect? It's not a perfect circle, but I have that cross section. Right? I have that cross section. What is it going to be? It is going to be an ellipse. So you can see here now that over here I have the cross section, and that cross section right there, it's intersected at an angle. And here is my cross section of my ellipse. It looks like an ellipse there. So here it's going to be an ellipse. All right. Now let's go to our next one. Plane intersecting base and parallel to the edge. The key word here is parallel to the edge. If it is parallel, meaning it's parallel to this edge right there, what is it going to form? If it's parallel to that edge, that means that that plane will only intersect one of the cones. So in this case, it's only intersecting the upper napped cone. So if I take a look here and I want to move it so it only intersects one cone, but it's not going to form an ellipse or that, I have to keep on moving. Let's see, what do I have to move? So let's say we can move the slice up, right? And that still looks like an ellipse, but what's that? That is no longer an ellipse. That is a parabola. So once you have your figure, got me? That is going to form your parabola. So if I take a look at that, see it goes, there is an ellipse. If I move it, it's going to be a parabola. And the key is that if I want to look at it, we want it to be, if I move it, see that's a half an ellipse. Let's make it. If I want to make sure it's a parabola, what do I have to do? I have to have it parallel to up. See, that's not it because that's going to be a hyperbola. Right there, it needs to be parallel to one of the sides of that double napped cone. So say in this case, it's parallel to this side, we're dealing with a parabola. So in here, our answer is going to be a parabola. Now, the last one we're looking at is a hyperbola. Now, the hyperbola that they talked about, now be careful here. It's going to intersect both the top and the bottom. So if you look at that interactive activity, if I keep on moving this over, that's not going to work, that one. Let's go back over here so we can see it. I need to make it so that right there, that plane intersects both of the cones, the top and the bottom. This is going to be my hyperbola. It turns in a different direction. So that here is when it intersects, it's not parallel to the edge. The plane intersecting the bases and is not parallel to the edge will form a hyperbola. All right, guys? So those are your fill. Okay, now what we're going to do is find the area of some prisms, and we're going to look at the area, the cross sections of our prisms and pyramids. Now, or cones and cylinders. So we're going to look at a different, looking at them slightly differently. So let's take a look at this. If I look at the cross section in number 1, I have a regular pentagonal prism, and I have a base segment is 6 centimeters. What does that mean? That means that right here, my base is 6 centimeters right there. That's a base segment. Now, if I have a plane that is intersecting a pentagonal, in this case, a right pentagonal, and we're also going to say that it is regular because, well, it stated it was regular, so I know all my sides are congruent. A right regular pentagonal prism, I know that if I have a plane that is parallel to both bases, that cross section right here, that cross section will be congruent to both bases. So that I know that since I have a base segment is 6 down here, I also know that up here, this is also going to be 6 centimeters. Now remember, if we have a regular prism, our formula that we're using is A equals 1/2 AP. And we know our side length is 6. So perimeter is quite easy. The perimeter is just 6 times 5. So we're looking at a 30 centimeter perimeter. All right, guys, 30 centimeter perimeter. Now we have to find A. Now remember, if we find A, that apothem, what we're going to do is we're going to go from the center. Okay, guys, we're going to go right from that center down. It's going to be perpendicular. And we're going to make that little right triangle. Right here is A. Now be aware that now if I look at this segment here is 1/2 of 6. So that will be 3. Now, in order to figure this out, we have to also recall that when we look at this, we need to find some angles. So I can draw this bigger triangle. I didn't want it in blue. We'll do it in red, that bigger triangle. And I know that when I take a look at this, the inside angles all add up to 360 degrees. So I can make 5 triangles out of my pentagon. So I take that 360 and I divide it by 5. Now I get 72 degrees. Now that is the big angle up there. So if I pull out that triangle, that right triangle, the angle up here will be 1/2 of that 72, which will be my 36 degrees. Here's A, and this is 3. So to find A, I would use my trigonometry. Compared to 36, I have opposite and I have adjacent. So I would say the tangent of 36 is equivalent to 3 over A. I would multiply both sides by A and then divide by tangent of 36. So it would be 3 over tangent of 36. Now let's take a look, guys. What is that going to be? So if I input that into my calculator, I'm going to get 4.129. So now go back. What is that area? What is my area going to be? Well, your area is going to be 1/2 that 4.129 times that 30, which is our perimeter. So if I put that in my calculator, the area will be approximately 61.937. 937 in its area, so it's centimeters squared. That would be my area for the cross section of this regular pentagonal prism. All right, so now let's take a look at number 2. If I look at this right cylinder, it's being cut perpendicularly by a plane that includes the diameter, meaning they're telling me that this here is my diameter. The distance between the 2 circular bases is 8 centimeters. That is going to be the length here between the 2 circular bases. So now we're dealing with my diameter. They told me is and look at this, the distance between is 6 and the radius is 3. Well, if the radius is 3, my diameter is 6 centimeters. And I know the distance between the two is going to be 8 centimeters. So because that's a rectangle, we're just going to multiply. We're going to do 6 centimeters times 8 centimeters. And the area of that cross section will just be 48 centimeters squared. Excellent. All right, guys, your right cone. Now you have a right cone that is cut by a plane that's parallel to the base. Well, if it's parallel to the base, I know that this is a circle. All right, so if it's a circle. It's a smaller circle than the base, but it is a circle. Now the diameter of the circle formed by the cross section is 2 centimeters. So they're telling me that the diameter of this is 2 centimeters. So to find my area, I'm just going to do area equals pi r squared. Well, the radius would be 1 here, guys. So area is pi times 1 squared, which is just pi. And again, it would be centimeters squared. All right, guys. I want you to finish the 3 problems on this worksheet for your assignment and then your attached review, the review below for your assignment today too. I hope you have a great day, and I will see you tomorrow at our Google Meet review. All right. Bye, guys.